makes this boil. Actually, even dry ice will make this boil. Because dry ice, or solid carbon dioxide, is only about 190-something degrees below zero. Now, why did I bring liquid nitrogen? Well, number one, it's really cool to look at, and I can do some really cool stuff with it. But more importantly, what I want to do today is I want us to look at what happens to matter when you heat it up or cool it down. Now, you've heard of matter, right?
Yes.
It's all matter, all this stuff around us. And matter comes in three basic forms: solid, liquid, and gas, of course. Now, the state of matter that something is in depends on what it's made of and what temperature it is. A simple example would be water. At temperatures below 32 degrees Fahrenheit, water is more commonly called ice. And that would be a... Now, if you want to turn that solid into a liquid, what do? You heat it up. You add heat. And also, you're adding energy. Because heat is a form of energy. At above 32 degrees, ice will melt. Solid will turn to liquid. Now, liquid water can also be heated, and at above 212 degrees, water will begin to boil or evaporate. And that is turned from a liquid into a gas. And then you get water vapor, which is water as gas. But you can also make it change the other way. If you want to take water vapor and turn it back into a liquid, what are you going to do? Make it colder. Now, you don't make it colder by adding anything, because there's no such thing as cold energy. You make it colder by removing heat. And when you remove heat, you lower the temperature. A gas will turn to a liquid, that's called condensation, and a liquid eventually will freeze and turn into a solid. And you all know this is pretty much the basics, but there's more. There's other things that happen when you make things hotter and colder. I'll show you. And as you can see, the bimetallic strip is now curved. Now here's why. When you make things colder, they get smaller. The size of something will change with temperature change. It's just that certain things will shrink more than other things. This metal shrinks more than this metal when you cool them down to the same temperature. That's why it curved. But my hands are about 400 degrees hotter than the liquid nitrogen. So simply by using the heat from my body, I am warming or heating this piece of bimetallic strip back up. And as I do that, what do you think is happening? Well, if making things colder makes them get smaller, then you might guess that the opposite happens when making things hotter, when making them get larger, bigger. They would expand. And in fact, the metal has expanded again. I warmed it back up to its original temperature, and the metals have expanded back to their original size and shape. Now, in science, this is something we call thermal expansion. Basically, thermal heat expansion, getting bigger. And then, of course, the opposite is true. So, making things colder makes them shrink. Making things hotter makes them get bigger or expand. Because the ball is bigger than the hole. But there is a simple solution. Yes. Liquid nitrogen, because that will make it shrink. Because obviously the liquid nitrogen is going to make it get colder. I like this idea because if it works, it will demonstrate what I'm trying to show you. Kevin, don't worry, they couldn't see what's happening. That ball is solid metal, so it's going to take a while for it to cool all the way down, all the way through to the center. But see, here's size. That way, we can use it to see if the ball actually does, in fact, shrink. But for now, thank you very much. Thank you very much. Nice round of applause. Now, while we're waiting, there's a solid that has a very interesting property. It is elastic. What that means is that, well, when this ball bounces, basically what happens is the ball squishes to absorb the shock of hitting something. But then when it bounces back, it always goes back to its original shape. And things that bounce tend to be elastic. Even things that seem very hard, like a big. But what if I took a rubber racquetball and made it 400 degrees colder? Do you think it would bounce better or not as well? Well, we can try. Because I, in fact, have taken a racquetball and cooled it down using a liquid nitrogen. So let's see if it bounces as well as the first ball. A molecule is the smallest amount of matter you can have where it still has the properties of what it is, matter. You break down molecules and then you have atoms. But molecules, although by themselves are usually very small, a lot of them come together and then they make up stuff, matter. The thing is, with solids, the molecules are generally very close together.